Hello and welcome to the normal probability video. My name is Bo Corkins and this is statistics. So, want to jump into a couple examples here. The average salary for first-year teachers is $27,989 if the distribution is approximately normal with a population standard deviation of 3250. What is the probability that a randomly selected first-year teacher makes these salaries? So we're starting with 20,000 or less. So let's identify our information. So the problem is stated normal. We have a mean and a standard deviation. And if it is stated normal, that tells us what we are going to be looking for picture-wise. And then I want to identify less than 20,000. Less than means I shade to the left. And I identify Z equals observation minus the mean divided by the standard deviation. All right, our formulas are really simple. The calculation is very simple. When you put this in your calculator, make sure you put the numerator in parentheses when you do this calculation. That should get negative 2.46. And then we get to look these values up in our new table, the Z table. So the table is read two-dimensionally. All right, the first decimal is along the column, the second decimal is along the row. So negative 2.4, right, is right here. Then I track it with 0.06. So then I match those up to get the value that they correspond to. Negative 2.46 yields a z-score of 0.0069. The z-score of negative 2.46 yields a probability of 0.0069. And with all probabilities, we need a probability statement. So the probability statement is, in this case, I'm going to call teachers T, all right, less than 20,000. Now I could do less than or equal to, well, not in this case, but as a note, less than or equal to mean the same thing with continuous data because the probability under a single line is 0. So whether it's less than or equal to, or greater than or equal to, we never really put the equal sign, just so you know. Also, all right, look in those values directly up when you have a left probability because the Z table is areas to the left. If I need to look up an area to the right, I need to subtract from 1, all right? But not in this case. So similarly, less than 30,000 a year. And then less than means shade to the left. Which calculates us a value of 0.62. Looking that value up, so 0.6 and then 2 gives us a probability of 0.7324. And a probability statement T less than 30,000. So again, our calculations, very, very simple, very straightforward. We have a simple equation, all right, and then you need to follow that up by using the z-table. Putting those two together, what's the probability first-year teachers make between 20,000 and 30,000 a year? That means I am now looking at this picture. So I'm now looking for a middle probability. Well, the good news is for this one, we've already calculated the values we need. A big probability minus a little probability will yield a middle probability. The area to the left, all right, of 30,000, take away the area to the left of 20,000 gives this middle area, because that's everything to the left of 30,000 is that. Then I just take that out, all right, and I can calculate. Since I just found those two values, the area to the left of 30,000 is 7324, and the left of 20,000 is 0069. When I subtract those values, that gives me 0.7255. And then lastly, I need a probability statement. For middle probabilities, 20,000 is less than t, which is less than 30,000, which, just to keep the notation, I'm going to put 30K, 30,000. So these probabilities, all right, make sure it's less than, indicating that it is a middle probability. All right, the average price of a personal computer is $949. The computer prices are approximately normal distributed with a population standard deviation of $100. The least expensive 10% of personal computers cost less than what amount? So this is now in reverse, okay? So I have this percentage and I'm trying to work backwards to find a particular cost. So let's identify our information still. The mean is 949. Standard deviation is 100. And picture is worth 1,000 words. 949. Then the least expensive computers are down here, right? The lowest costing computers would be this number, let's call that X. And this shaded region would be 10%, the least expensive personal computers. Now this means I need to look at the z-table in reverse to find, right? I need to look inside the z-table for 0.1000, as close as I can get, and find the z-score. All right, so let's look inside the table. So for the value that is closest to 10%. So, okay, look, right here, that's about 3%. Oh, I'm around 10%. And oh, look, here is the value closest to 10%. 0.1003. Just get as close as you can to the value you're interested in. That corresponds to a z-score of negative 1.28. All right, so this is using the z-table in reverse. Instead of starting on the outside and going in, we started on the inside and went out. So that corresponds to a z-score equal to negative 1.28. Now we can use our equation in reverse. Z equals observation minus the mean divided by standard deviation. The z-score is negative 1.28. My observation we defined as x. My mean is 949, and my standard deviation is 100. Then, all right, simple calculations, multiply by 100, add 949. I'll leave the algebra to you. X equals 821. And then always make sure your questions either have a probability statement or units. In this case, we are in context and we are looking for the cost, dollars. So a personal, the least 10% of the cheapest 10% of personal computers cost $828 or less. All right, so lots more normal probability questions that you can see in the activities. Again, if you have to find a probability to the right, make sure you subtract from 1. All right, the graph is symmetric and sums 100%. Otherwise, have a wonderful time and enjoy.